Present value and future value. Let's assume two individuals, Mr. A and Mr. B. Now, Mr. A has lent some money to Mr. B and Mr. A would be charging interest from Mr. B. There are two methods of charging interest. One, simple interest, which, as the name suggests, is simple in calculation. So the formula for simple interest we all know is loan amount into number of period into the rate. So for example, if the loan amount is 50,000, period being 2 years, and the interest rate being 10% per annum, our interest amount comes to 50,000 into 10 by 100 into 2, which is 10,000. When we add this to the principal amount, we come to our present value and future value. So the present value is the original amount lent by Mr. A to Mr. B, and the future value is the amount which Mr. B would pay back to Mr. A, which is principal amount plus interest, 50,000 plus 10,000, which comes to 60,000. Now the other method of calculating interest is compound interest, which is essentially a little complicated but more commonly used method. So in case of compound interest, the principal amount changes the subsequent year because the interest amount of the current year is added to the original principal amount to make the principal amount of the next year. For example, using the same numbers as in our example for simple interest, for year 1, the interest amount using the compound interest would be 50,000 into 10% into 1, which comes to 5,000. But for year 2, we'll add this 5,000 with the original principal amount of 50,000. So for year 2, the principal amount becomes 55,000. We'll calculate interest on this, which comes to 5,500. Hence, in case of compound interest, the present value, while being the same of 50,000, the future value would be 60,500 because the interest amount has changed. We also have a formula to calculate the compound interest, which is FV, future value equals to PV, present value, into 1 plus R by 100 to the power N, where R is the rate of interest and N is essentially the period. We may also be asked to calculate the present value from future value. So we just tweak the formula a little. So present value is future value divided by 1 plus R by 100 to the power N. So when we calculate future value from present value, we multiply 1 plus R by 100 to the power N with present value. And when we calculate present value from future value, we divide 1 plus R by 100 to the power N with future value. You may also be asked to calculate the compound interest semi-annually. So, unless provided, the compound interest is always assumed to be calculated annually. But in cases where compound interest is calculated semi-annually, you divide the interest rate by 2 and multiply the period by 2 again. So, in this case, future value is calculated by multiplying the present value, which is 50,000, into 1 plus R. Now the original R was 10%, but we have divided it by 2. So the now with when the interest is compounded semi-annually, the rate becomes 5% and not 10% to the power 4. In our previous example, when interest was compounded annually, the interest was calculated, the period was 2 years. But now, since the interest is calculated compounded semi-annually, we've multiplied the period by 2. So now the period has become 4. So you see our interest amount has increased slightly. Similarly, if the interest is compounded quarterly, you divide the interest rate by 4 and multiply the period by 4. When the interest is calculated monthly, you divide the interest rate by 12 and multiply the period by 12 again. Before we move ahead, it is important to understand the concept of time value of money. We all know that the value of money diminishes over time. For example, a sum of money, let's say 5,000, holds the value today, but it may hold the lesser value, say 10 years from now. So the quantity of stuff that you can buy with that 5,000 rupees today, you may not be able to buy the same quantity 10 years from now. and even the lesser quantities 20 years from now. Now, in most of the cases, this value of money is reduced because of inflation. So it's the inflation that makes the money. So how do we calculate the future value of money, which is on a diminishing trend mathematically using a formula? Say you have 50,000 today, and the discount rate, which is the rate at which your money would lose value each year, is 5%. Now, what would be the value of 50,000 each year for 4 years? We try and remember the formula that we used in compound interest calculation, where we calculated the future value. So the future value would be calculated as present value divided by 1 plus rate to the power year, which is n. Now, rate here is the discount rate which is provided to us. So let's calculate this 50,000, the value of 50,000 each year from today for the period of 4 years. So at the end of year 1, using a discount rate of 5% and using the formula where 50,000 is the present value divided by 1 plus rate, which is 5% to the power 1. 1 is the number of year. Our amount comes to 47,619. This means that at the end of year 1, meaning after 1 year, our 50,000 would lose its value and would be equal to 47,619. That means 50,000 today is equal to 47,619 1 year from now. Using the same calculation, at the end of year 2, our value would be 45,351. Notice that the n, which is the period, has changed from 1 to 2 here. So on and so forth. The values at the end of year 3 and year 4 are 43,192 and 41,135 respectively.